Today we're going to talk about 2.5 linear functions and models. And so, the equation of a line is mx plus b. Then I hear they're talking about linear functions. So they're looking at functions of this form, f of x equals ax plus b. Okay, now, so with a linear function, you still have the slope m of a line corresponds with the linear function's variable a here. And then these also correspond. Now, if it's the equation of a line, this is known as the slope, and this is known as the y-intercept. For a linear equation, this is known, the a is known as the rate of change. And this rate of change is constant. It's a number. It's a value a. So like if the line had a slope of 5, then the corresponding linear function would have a rate of change, or a constant rate of change of 5. And then this is the b right here is known as the initial value. So essentially, this is just a line right here. You can think of it as a line. Completely think of it as a line. But instead of calling it a slope, you call it a constant rate of change. And instead of calling it y-intercept, you call it an initial value. That's the only difference. Okay, so let's get into the exercises. So number 1, let f be a function with constant rate of change. So that constant rate of change is your a here. Then f is a linear function. And it's of the form ax plus b. And the graph, of course, is a line. Okay, let's get to number 2. Now here's an example. And again, in this example here, a is negative 6 is the a here. So it's the constant rate of change. And so that's negative 6. And then the graph is a line. The slope is negative 6. The y-intercept is 4. Okay, so with a line, this is known as this is the constant rate of change is the negative 6, and the 4 is the y-intercept. But it's as far as linear function, it's the initial value. Okay, so let's go ahead and go on to number 3. Number 3, a swimming pool is being filled. The graph shows the number of gallons y in the pool after x minutes. Okay, so now they want to know what is the slope of the graph, and this is also going to be okay. So the slope, what you can do is just choose any 2 of these points that are on that you know exactly where they are. Just any 2 of them, any 2 different ones. So probably let's choose this one. This is the easiest. So the x coordinate is 0, the y coordinate is 20 for this point right here. Okay, for this point, I'll do it in green. For this point, the y coordinate is 1. The x coordinate is 1, and the y coordinate is up here at 40, because it goes 10, 20, 30, 40. So that's 140. Okay, so here are 2 different points. So the slope will be the difference in the y coordinates divided by the difference in the x coordinates. So that's going to be 20. So the slope is 20. Number 4 has exactly the same graph right here, but it's asking what the rate at which it's being filled. And the rate is the same as the slope. So it's going to be 20. It's also going to be 20 gallons per minute. Okay, so the rate is the same as the slope. And that's also, as far as linear functions, again, that comes out again as the constant rate of change. Okay. Okay, let's move along to number 5. If a linear function has a positive rate of change, does its graph slope upward or downward? Okay, so the answer is that one is exactly what you think it is, and the answer is upward. And this, of course, is all this is as you go from left to right. Okay, because if you're going from, it's sloping upwards, okay, so it's going to be a line like that. As you're going from left to right, then it's going up, right? But if you go from right to left, of course, it's going down, okay? But left to right is usually the positive direction. So as time goes by, it's like if this x variable were time, then it would be time going by, and of course, it's going to be going up or increasing. Okay, number 6. So is f of x equals 5 a linear function? Okay, so this is a little bit tricky because, again, the linear function is of this form right here, ax plus b, but you are allowed to have a equal to 0. A and b can be any real numbers that you want, and you're allowed to have a being equal to 0. So, and then b being equal to 5. So the answer to this is yes, because if you just take a to be 0 and b to be 5, then it fits the model. Okay, so the slope is going to be 0, and the rate of change, well, that's the same thing, is also going to be 0. So the slope and the rate of change are both 0. Okay, number 7, determine whether this function is linear. Now, again, if you rewrite it, you can rewrite it in this form. This has the ax coming first and then plus b. So you just rearrange it. So it's negative 6x plus 4. And so a is negative 6 and b is 4. So the constant rate of change is negative 6 and the initial value is 4. Okay, so the answer here is yes. And this is, and if you write it f of x equals negative 6x plus 4, that does the trick. Okay, number 8. Determine whether this function is linear. Okay, so what you can do here is you can just, because you have two different entities in the numerator, then you can, and only one thing in the denominator, then you can split up like this. Okay, if it's the other way around, you can't do that. So you can go like that, okay? And then you can think, okay, the x's are going to cancel here. But see, that's never going to be, you can never get into this form because it's 5 over x. It's not, so this is, the answer here is no. It's not linear. Okay, so you just say not linear. That would be the answer to number 8. Okay, let's take a look at number 9. Here we're supposed to, well, 9 and 10, we're going to go ahead and do those in, Webassign. But let me just give you a really quick one down here. The slope is, I'll just do it by hand really quickly. So here the slope is negative, or what you want to do is you want to go to the y-intercept first, down here at negative 7. Grab that first, and then incorporate the slope. As you go over 1, you're going to go down 5. Okay, so it's going to be something like this. So you go down 5, and you over 1. It's basically from this point, you go down 5 over 1, and you get the slope. And so then you fill that line in. Okay, so the slope is negative 5, and the rate of change is negative 5. Okay, so those are going to be the second answers. Okay, so let me flip over to Webassign to do this right here. Okay, so here's the exercise on Webassign. And what you want to do is you want to select the line tool, which is this one. So make sure that's highlighted in blue. And then, like I said, you find this y-intercept of negative 7, which is right here. You click it right there. That's your first point. Now I did say I go down 5. Now that I look at it, it's not going to work because it doesn't go down past to negative 11. So what you can do instead is you can go to the left by 1 and up 5. Okay, so adding -7 plus 5 is -2, but I'm going to the left. Okay, because the idea is that it's still gonna be on the line because -5 can be written as +5 divided by -1. Okay, so and then remember the slope is the rise over the run. So so +5 means going up, but then -1 means going to the left. Okay, so that's gonna be the line. And then the slope again is -5 and -5. Okay, so I'll go ahead and submit that answer. And yeah, so that's correct. That's number 10 also. I'll go ahead and do that one. So again, it's a line. So select that, make sure that's blue. That's highlighted in blue. Then we're going to pick off the y-intercept, which is -13, right there, -13, and then 5/4. So the slope is 5/4. I'll go ahead and write that down right there. So 5/4, which is the constant, which is the rate of change as well. So again, slope is rise over the run. So if I go up by 5, so from -13 plus 5 gives me going up 5 and across 4. And that should give me the correct answer. It didn't. Let me see. Did I go over 4? Okay, so I'm really confused here now. Oh, okay. What happened was, okay, I was confused. I thought this was the y-axis, but it's actually the y-axis is actually over here. So let me go ahead and clear that. Okay, so that's right there is you're on the y-axis right there, and these numbers were over here. Okay, so up 5 and over 4 to right there. Okay, and we'll submit that. Okay, so there we go. Okay, okay, let's go back over to the other document. Again, we did the sketch on on Webassign, and again, the slope and the constant rate of change is 5/4. Okay, number 11. The linear function g has a rate of change of -14. That's going to be our A. And initial value is 700. That's going to be our B. Okay, so then it's going to be -14x plus 700. That will be the answer. I believe it's just that right there, the circle. Okay, moving on to number 12. The graph of a function is given. Okay, so here we're supposed to find the rate of change, and then we're supposed to express it in these terms right here. So the easiest thing is to identify 2 points that are at intersections here that you can tell exactly what the coordinates are. So here we can tell what the coordinates are. Those are 0, 4, because it's 0 in the x direction and 4 in the y direction. Okay, and then another point that we can tell where it is would be this point right here. And this is 2, 0, because that's 1, 2, and then this is 0 as far as the y is concerned. Okay, so the slope is going to be the difference in the y coordinates. We take this one minus that one, 0 minus 4, divided by 2 minus 0. So that's negative 4 over 2, which is negative 2. And the slope is the same as the rate of change, so that's going to be negative 2. I express f in this form. This is the y-intercept, which is also the constant rate of change, or b equals 4. So that b is going to be 4. And a is negative 2. So negative 2x plus 4. Okay, number 13. Jade and her roommate Jari commute to work each morning, traveling west on I-10. One morning, Jade left for work at 6:50 a.m., but Jari left 10 minutes later. Both drove at a constant speed. The following graphs show the distance in miles. Each of them has traveled on I-10 at time t in minutes, where t equals 0 to 7 a.m. Okay, so here's the graph. And which is traveling faster? Well, Jari has a slightly steeper slope, so Jari is traveling faster. Okay, now we want to find the speed of each. Or the constant, the speed would be the rate. Speed is rate, it's on, or constant rate of speed, or constant rate of change. So let's go Jari first. So there, you identify that there's 2 points. This point is 0, 0. That point is 6, 7. So for Jari, the constant rate A is also the slope, or the difference in y coordinates, 7 minus 0, divided by the difference in x coordinates. So 7 minus 0 over 6 minus 0. That's 7 over 6. Now, one thing, though, you have to realize at this point is that's not going to give you the right answer, because they want it in miles per hour, and we have to figure out what units are these. This numerator is miles, but the denominator is minutes, okay, because they're talking minutes. So we have to convert this into miles per hour. Well, so the way to do that is to multiply by 1, a fancy form of 1, where you have minutes here and hours there. Okay, so you want this numerator has to be equal to the denominator. And we know that there are 60 minutes in 1 hour. So 60 minutes and 1 hour are equal to each other. That means that this divided by this is 1. We're multiplying by a fancy form of 1 is what we're doing. Okay, so when you do that, the minutes are going to cancel. This 60 is reduced to 10. So you get 70 miles per hour. So notice miles is in the numerator, hours in the denominator. So Jade is going 70 miles per hour. Okay, I mean Jari. Oh, wait, what am I? So Jari is doing 70 miles per hour. Okay, now Jade. For Jade, again, you calculate the slope. This is 16 minus 10. So this point right here is 0, 10. The x coordinate is 0. The x coordinate is 0. The y coordinate is 10. Okay, so this is going to be 16 minus 10 over 6 minus 0. Okay, so that's 6 over 6, which is, well, this is miles and this is minutes. Okay. And so that's 1 mile over per minute. So again, you're going to multiply by this by 60 minutes per 1 hour, multiply by 1 basically, and minutes are going to cancel, and you're going to have 60 miles per hour. Okay, so Jade is going 60 miles per hour. now we're going to write each of these as a linear function. So the constant rate of change for Jari is 70. So 70t. She started at 0, so that's just plus 0, or just 70t. Wait, hold on a second. It's supposed to be in minutes, okay? So that means, what that means is that for this one, we're going to go back to this place right here, okay? Okay, so for Jari, it's 7/6t. For Jade, this is just 1 here. So that's going to be t, but her initial value was 10. So t plus 10. Okay, let's go to number 14. The manager of a furniture factory finds that it costs $2,200 to produce 100 chairs in 1 day, and $4,800 to produce 300 chairs in 1 day. Okay. So I'm just a quick look down here at the graph. You have to figure out which is the independent variable and which is your dependent variable. Or in other words, the x is independent variable and y is your dependent variable. So you have to, it's good to figure out which is which. All of these graphs have the cost on the y-axis and the number of chairs on the x-axis. And that also makes sense because, you know, you say, okay, I'm going to produce this many chairs. You decide how many chairs you're going to produce, and then the cost comes after. Okay, it's not like, oh, let's just decide how much money we're going to spend and then see how many chairs we're going to produce. I guess you could think of it that way, but generally you'd say, okay, how many chairs are we going to produce? Produce those number of chairs and then see what the cost is. Okay, so that means that 100 comes first, and then the 2,200. So all of this is 1 point, and all of this is another point, 300, 4,800, and put it in this way. Okay, now those are 2 points on a graph, or 2 points on in the linear function, and so we can find the constant rate of change or the slope by using these 2 points. Okay, so the numerator is the difference in y values, and the denominator is the difference in x values. Okay, so this is 4,800 minus 2,200 is 2,600. 300 minus 100 is 200, so we got 1,300. Okay, so the 1,300 is no, wait. 13. I forgot. You're gonna cancel these out. Okay, so 26 divided by 2 is that's 13. Okay, so 1,300 is, or 13 is going to be the slope of the line. So we can go ahead and put a 13 right there. Also, the cost is going to be 13x, but then there's going to be plus some other value here. Okay, but we can go ahead and figure out what that is. Because we know it's linear, so that means it's, and we know the slope is 13, so it's 13x plus b. And the idea that what we should do now is plug one of these 2 points in. This one's probably the easier one because of the smaller numbers. We'll go ahead and plug that number into here. So plug a 2,200 in for the y and a 100 in for the x. Okay, so y gets replaced with this y value, x gets replaced with the corresponding x value. Plus b. This is 1,300, and we'll multiply those together. subtract 1,300 from both sides, and you have 900. Okay, so B is 900. So we're going to head put 900 right there. And then go ahead and figure out which one of these. So the initial value is 900. So that means that the y-intercept is 900. So that looks like that's okay. This is not okay because it should have a value here. Again, the value should be here. So this is the only one that can happen. And it does look like the slope is 13. So this one is what it is. Also, right here it says at what rate does the factory's cost increase for each additional chair produced? And the answer is $13. So it costs $13 for each additional chair that's produced. The 900, you could think of that as just like fixed cost that you have to pay no matter how many chairs you do. I mean, if you even just let the factory sit and do nothing all day, then you're going to still have to pay this cost right here. And then you can think of the 13 as the materials for that are needed for each chair.